equal to m times x minus x1. Now plug them in. Y minus y1 is 2 equal to m is 1/2. X minus x1 is 1. You see? M is 1/2, and the point is x is 1, y is 2. And then simplify. Y minus 2 equal to 1/2 of x minus 1/2. You add 2 on both sides. 1/2 of x minus 1/2 plus 2. So y equal to 1/2 of x plus 3/2. And you have the answer. This is a line with slope 1/2 and y-intercept is at 3/2. Okay. You guys see the first example right here. Whenever you guys have 2 points, you should be able to find the equation of the line. And the strategy is what? You know, in general, for all kind of line, you look for the slope and a point. Okay? For 2 points, you use the equation for the slope, find the slope, and 2 points, you have a point already. Plug in, use the point slope equation. This should be in your pocket. Second example. Example number 2. Equation of a line containing a point. And is parallel to another line. So another line. Okay? So graphically, what they give you is what? There's another line right here. And they give you a point right there. So you have a point, and you know that the line that you're looking for is containing this point right here. And that line is also parallel to the given line. Okay? So this is the line that you're looking for. Okay? So how do you find that line? So let me give you an example. This point right here, how about 1 comma negative 2? Just random number. And the equation of the second line is y is equal to 2x minus 1. So you find the equation of the line, the blue line right here. You're looking for the equation. That's what I claimed before. You're going to need 2 things to find the equation of the line. You need what? Slope. And you need a point. Well, the point is given right here, 1, negative 2. So I got the point, 1, negative 2. And the slope. Do I have slope? I don't. But what do I know? The blue line is parallel to a given line. I do know the slope of the parallel line, m equal to 2. And according to what we learned before, 2 lines are parallel if they have the same slope. So this slope equal to 2. Therefore, slope of the line that we're looking for is also 2. Okay, so slopes I know as well. M equal to 2. And then you are okay to write equation on line. You have slope and a point. So using the point slope formula, y minus negative 2 equal to 2 times x minus 1. See? Y minus y1 equal to m times x minus x1. y1 is negative 2 and x1 is 1. This is x1. This is y1. Okay. This is what? Y plus 2 equal to 2x minus 2. Subtract the 2 on both sides. Y equal to 2x minus 4. I have the answer. So you guys get a hang of it so far, hopefully. We need to find the equation of the line. This is a very general, typical type of problem that we see throughout math courses in algebra. And usually what you need is slope and a point. Okay, last example for this section. Instead of being parallel, now you can guess, I'm going to change the word parallel to perpendicular. Okay. And perpendicular to another line. So this is what you see graphically. what they give you is a point. What they give you is a line, okay? And what they ask you is to find the equation of the line that goes through that point. But now it's not parallel to the second line anymore. It's gonna be perpendicular. Oh, I gotta draw it back. It doesn't look like 90 degree. Perpendicular. Should be like this. Okay, that looks better. 90 degree. So what you see is a point right here. Let me just make an example out of it. This point is 2, 1. I choose easy number. And this line is, now make it a little bit harder. How about 2x minus y, 2x minus 3y equal to 6. Okay? So, do you want to find the equation for the red line right here? Again, you guys are going to need two things. You're going to need two things. You need what? Slope and a point. Always need slope and a point, unless you have a vertical line, but that's easy to take care of. Just x equal to a constant, right? That's extremely easy. So in general, a line going to have a slope, and an equation going to need two things, slope and a point. Okay, the point is given right there already. The point is 2, 1. Now the tricky part is to find a slope. I have a line right here, but I don't even know the slope of that black line I have right here, because the equation for this line is given in the general form, okay? So I have to somehow modify my general form to get the slope out of it. Okay, let's solve for this. Subtract the 2x on both sides, so I got negative 3y equal to negative 2x plus 6. I'm going to divide both sides by negative 3. I got y equal to 2 over 3x minus 2. Okay, divide both sides by negative 3. I got this. Okay, so the slope, I can see right here, slope m is 2 over 3. All right, so I got the slope of the black line. How do I find the slope of the red line if I know that the red line is perpendicular to the black line? And we learned that the slope of the perpendicular line is going to be opposite reciprocal. So the slope of the red line is going to be negative 3 over 2. All right, so slope is m is equal to negative 3 over 2. Right. You see, I show you the strategy step by step. This is important than the answer. Okay, so make sure that you understand it. That things going to come out. Doesn't matter which class you take later. You have slope, you have a point. You can find the equation of the line. Y minus 1 equal to negative 3 over 2 of x minus 2. See? Y minus y1 equal to m times x minus x1. So y minus 1 equal to negative 3 over 2x plus 3. Distribution. And add 2 on both sides. Add 1 on both sides. And then y equal to negative 3 over 2x plus 4. You have the answer. Okay, so this is the end of section 2.3. We learned quite a few things in this section, right? Because everything was all about line. What? Slope of the line and type of equation of the line. We have point slope equation, slope intercept equation, general equation, and then the vertical and horizontal line. And then we have what? Parallel lines, we have perpendicular lines, and I show you the examples of how to find the equation of the line given some conditions. And it doesn't matter what they're talking about. Whenever you see the question, they ask you to find the equation of a line, you are looking for two things from me. Number one, you look for slope. Number two, looking for a point on the line. After having slope and a point, you look into the equation, the point slope equation, you will have your line. Okay, and let me stop this section right here. Let me move on to the last section of chapter 2, and this is about variation, completely different from what we learned so far. We skipped 2.4, okay? We jump right to 2.5. 2.5, variation. In this section, we are studying about the relationship between two variables, or maybe 3 or 4 variables. See what happened if you change variable? what happened to the other variable if you change one? For example, you want to study about the distance you drive versus your speed, velocity. Right, distance versus speed. And you see what? The faster you drive, okay? Make it time. The faster you drive, given the same time. Given the same time, okay? Same time. If you're driving the same time, but you drive faster, then you can go further. In other words, you increase the speed, you're gonna increase the distance, okay? And make sure that you don't get pulled over. Okay? Or this, by the way, is called what? Direct variation, because if you increase one variable, the other is increasing. Okay? Say you want to study about the time you spend to study versus your exam score, and if you believe it, what? The more time you put on studying, then you have the highest score, and this is also the direct variation. You see, one variable increasing, the other is increasing. Okay. The other one is called the inverse variation. When you increase one thing, the other is decreasing. Say, for example, the fat amount in your body and the time you put on the gym, right? Fat amount is called X for the fat amount, and then Y for the time you put on the gym. And then what? The more time you put on working out, then the less fat we have on our body, and this is gonna be opposite direction. More time you spend on working out, less fat you have. This one called inverse variation, because the two variables moving on the opposite direction. What this? Say, think of, well, not now because we're in the pandemic, but say I used to work at the West Campus, right? So I had to commute from home to school. Distance is about 20 miles. And see what? I can study between what? The time versus the velocity or speed. And same distance, right? Same d. If I drive faster, spend less time. If I drive slower, use local for example, I have to spend more time, right? Because I drive the same distance from home to school. Okay? And those are inverse variation. Okay, now let's try to formalize what we're just talking about. First one, talk about direct variation. Okay, and in math we just use x, y for variable x, y, z. So I got y equal to k times x, and this is the general formula for a direct variation, where k is a constant. It's called the proportional constant, I think. Proportionality is k, just constant anyway. Constant, okay? And x and y is a variable. And you see what happened in here? When you increase x value, k is constant, never change, right? Then y will be increasing as well. Okay? So, in other words, y and x are moving in the same direction. X getting bigger, y getting bigger, and vice versa. We say that x and y vary directly with each other. I say this y varies directly with x. Okay. So whenever you see what y varies directly with x, you think of this formula for me. Okay. Second one's called the inverse variation. And the general formula for inverse variation is this: y equal to k over x. Now instead of multiplication, we have division right here, and of course k is a constant, x, y is a variable. And we say what? Y varies inversely with x. You see why? What happened when x gets bigger? K is a constant, stay the same. You divide it by a bigger number, you're going to get a smaller fraction. In other words, y is going to get smaller. The bigger the x is, the smaller the y is. Okay? Say what? Y varies inversely with x. Okay. So whenever you guys see that phrase, kind of put it in check what? D varies inversely with t or whatever, which is right x and y in general, but you just replace y by d, and then x by t, you have a general formula. Okay? And then third, let me talk about the combination of those. Number 3, combination. Means what? We may have more than 2 variables. We may have 3. You have this. Z is equal to k times x times y. So this, say what? Z varies directly with x and directly with y, right? So instead of saying z varies directly with x and directly with y, used to people say this. Z varies jointly with x and y. It means what? Vary directly with both x and y. Okay? It means what? X increase, y increase. X increase, z increase, y increase, z also increase. Okay? An example of this, you can say, remember this one, A is equal to L times W. Looks familiar? Sound familiar? A is for the area. And this is actually the formula of area of a rectangle, right? L stands for the length and W stands for the width. See? Z, X, and Y right here, constant is 1 already. And you see what happened right here? The area is going to get bigger if you increase in the length. The area is also getting bigger if you increase in the width. The answer is going to be getting bigger if you increase in both the length and the width. Or something like this. Say area is equal to what's that? Pi r squared. What is it? I think this is the area of a circle, right? So this is what? Area vary directly with r squared. Okay? So what? The constant k is pi already. And whenever r getting bigger, the area is getting bigger. Okay. And this is the first combination. What if you have a combination like this? Z is equal to k times x and then divided by y. Mark that for me. And they say what? Z varies directly with x and inversely with y. Okay. So direct multiplication, inverse division. It means what? When x getting bigger, the numerator getting bigger, of course z getting bigger. When y getting bigger, y is on the denominator getting bigger, the fraction getting smaller, y gets small, z getting smaller. X bigger, z bigger directly. Y bigger, z smaller, inversely. Okay. So those are the formulas you guys are gonna see in 2.5. And of course, the last part is always examples. Right? I'm gonna show you a couple of examples, and you guys can get the hang of it. Example number 1. Number 1, number 2, number 3, 4. Example. Okay? Start with the first example. Say this. A varies directly with x squared. Oh boy, x squared, okay? And A is equal to 4 pi when x equal to 2, okay? The question asks you to find the equation. Find the equation. All right, so I look at the first sentence right here. What A varies directly with x squared. So A is equal to, doesn't matter what, I will start with a constant k, you see? All the formulas going to have a constant k. Times something or divide something. And I see the word directly, so I know it's I multiply. Directly with what? With x squared. K times x squared. I'm done. I have the formula. Okay? Now, they give you more numbers to plug in to solve the equation. And I got A equal to 4 pi and x equal to 2. So I know what? 4 pi is equal to k times 2 squared. This is equal to 4k. I can solve for k from here, divided by 4. I got pi is equal to k. And k is a constant, never change, always equal to pi. So my equation is this. K equal to pi, right? So I got a equal to pi x squared. That's what I have. Okay? And I think I just talked about this a minute ago. This is what the area of a circle. All right? And they may ask you a bonus question. When x equal to 3, what's a equal to? That's x equal to 3. What is a equal to? See? A bonus question. Of course, you have a formula already. You got k solved. You can solve for a after this. Is a is what? Pi x squared means pi times 3 squared is 9 pi. X equal to 5, and you find a. Or you can say, when a equal to 10, can you solve for x? Okay. I'll leave that for you. But the first example, a varied directly with x squared. How about another example? Example number 2. F varies inversely with square root of d. Okay? And then f equal to 10 when d is equal to 4. Find the equation. Find the equation. We're going to go through the same steps we had before. First of all, we read the equation. We got what? F varies. Right? So I don't know what happened. Let's just start with the constant k first. Okay? I see the word what? Inversely. Okay? So instead of multiplying inverse, I have to do division, right? So k and then divided by what? Inversely with what? Square root. Square root of d. It's not just d. Square root of d. Okay? So k divided by square root of d. Okay? Now you have the general equation already. Look at the numbers. See what you got. F equal to 10 equal to k over square root of 4. And we know square root of 4 is 2. So k over 2. Solve for k. Multiply both sides by 2, so k is equal to 20. Now you have the equation, so with k equal to 20. So f is equal to 20 over square root of d. And that is your equation. And of course, as I say, they may ask you a bonus question. What is f when d is equal to 9, for example? So say d equal to 9. What is f equal to? That's easy, right? Look at d equal to 9. F is equal to 20 over square root of 9, which is 20 over 3. Done. Okay. And usually I leave the answer as fraction because I don't want to convert to decimal. I don't want to do approximation if I know the exact answer. Just leave it that way. Okay. How about another example? Okay. So, next one. You see direct variation, inverse variation. What about the combination of those? Last example. Okay. Example number 3. M varies directly with square of x and inversely with square of d and square root of x, and inversely with square root of x, square root of x. Okay, and they give you information. M equal to 24 when x equal to 9 and d equal to 4. Find the equation. down to a couple of examples. I hope that you guys see the similarity of those type of problem. Okay. So what do we do with this? M start with this equal to, right? I don't care what happens, just K first. Constant. Directly with the square of x. Directly, I know I have to do multiplication. With what? Square of x, not square root, okay? Square. Square of d is d squared. And then inversely, inverse means division, right? With what? Square root of x, so square root of x. All right? And again, here, example, I choose d next. When you guys do exercise, they may choose different letters, but same idea. Okay? You got the formula. Then plug in the numbers. M equal to 24 equal to K times d squared is 4 squared, and then square root of 9 because x is 9 and d is 4. So 24 is equal to 16K over 3. All right? Square root of 9 is 3, 4 squared is 16. So K is equal to 24 times 3 over 16. So I think this is what? 24 times 3 is 72 over 16. Divided by 8 is 9 over 2 is 4.5. Or 9 over 2. I would prefer fraction, but I do both ways. Okay? So my equation will be M is equal to 9 over 2 of d squared over square root of x. And as usual, if they give you more numbers to plug in, say x equal to 16 and d equal to 1, and you solve them to plug in and solve. But anyway, that's everything about the last section of chapter 5, section 2.5. And I think our clip is long enough. Let me stop our lecture for this week today. And hopefully you guys have some ideas of how to work with this problem, with those problems. All right. Should you have any question, please contact me for help. Thank you very much for watching, and have a great week. Have a good day. Bye-bye.